It's 3 o'clock in the morning and I need to use the facilities. For the purposes of this video, I'll turn on the light, but normally I'd never turn on the light at night. I'd start over here on this magic invention, and then I'd come over here and I'll wash my hands at the sink, and then I'll stick my head in there underneath that water and take a good drink because I'm dying of thirst. Again, it's dark. I haven't turned on a light. I'm not wearing my glasses, but I know that it's going to be cold and delicious and safe. Most people think that this is all magic. The water comes out of here by magic. All of our human waste magically disappears there. There's more magic up in that shower. There's more magic down the hall in the laundry room. There's more magic out in the kitchen where we cook and do our dishes. Yeah, but hi. For those of us in the water industry, we know that it's not magic. We know that we've got to get the water from the river, treat it, pipe it all the way here, making sure the whole time that it's monitored and that it's safe. And then after we've flushed it down there, we've got to pipe it safely back to the plant and treat it once more before we release it to the river. That's our job in the water and wastewater industry. Want to help us out?
Hi, I'm Robert Holler. I'm the Executive Director of the Canadian Water and Wastewater Association. We are the national voice for the municipal water and wastewater sector. We are the professional association for Canada's water leaders. I'm excited to be part of this AquaHacking challenge for Western Canada this year. I'm not an engineer, I'm not a scientist, but I bring to you 20 years of experience in municipal utility leadership, and then 10 years with this Canadian Water and Wastewater Association. But I'm not alone. I've got engineering support from Professor David Teasdale of Okanagan College, and I'd like to introduce him right now.
Hi there, I'm David Teasdale. I'm a college professor at Okanagan College in the Water Engineering Technology program. I'm honored to be identified as a water issue leader in this year's 2021 Western Canada AquaHacking Challenge. I will be serving in a joint capacity with Robert Holler, who is the Director of the Canadian Water and Wastewater Association. In this role, I bring forth over 20 years of experience in both the operational and management side of large-scale water and wastewater institutions. I've been involved in several research projects in the past, working with students at other educational institutions, and as well as working with a number of industry partners and a lot of the local associations. When we think of innovation, most people think perhaps it's a reinvention of the wheel, and it's not. It's often looking at what we're doing now and trying to find new ways of doing it better. If you have ideas towards optimization of either water or wastewater treatment processes, the team of Robert and I look forward to talking to you, providing you guidance, answering your questions, and supporting you in this endeavor. Thank you.
So I'm going to go back to that magic I was talking about at the very beginning, that magic of water and wastewater. We know it's not magic. It's science, it's engineering, it's operational expertise. For this AquaHacking challenge, the theme was optimization. How do we do this? As Professor Teasdale said, it's about helping us to find ways to do it better. We hear the term circular economy a lot. There are three major elements that I see in the circular economy. The first is keeping resources in use as long as possible, making our equipment last. The second is extracting the maximum value of our resources and equipment while they're in use. And the third is to recover or regenerate products at the end of the service life. To me, it's more like the 3 R's: reduce, reuse, recycle. You can submit on any element of water and wastewater treatment. But if this year's theme is optimization, for me, I'm focusing more on that middle definition of extracting the maximum value of our resources while we've got that equipment and resources in use. So it's around concepts of efficiency and effectiveness, reducing waste or loss of water, reducing our downtime. We can affect leaks, infiltration, reducing the wear and tear of our equipment, things like pressure control, filter and pump maintenance. It could be about energy. It could be about reducing the energy we use, which reduces our costs, but it also reduces our greenhouse gases that we're releasing. It could be about more efficient equipment. It could be about using gravity better. Maybe it's about alternate energy sources. Maybe you're looking at creating energy, generating or regenerating energy from what we're doing. It could be our ability to use our waste, maybe fertilizer from biosolids or effluent for cooling or irrigation. But our financial resources are limited. We can't just fix everything and replace everything all at once. We have to know in optimization what to fix and when. So a lot of work will go into monitoring our systems, collecting data, and then analyzing it, more of a forensic auditing, so that we know where to put our efforts and our resources. That'll make all the difference. So the world of water and wastewater utilities is vast and it's varied. It's all fascinating. There are so many elements that have to come together: water sciences, mechanical engineering, efficiency, water reuse, security issues and resilience, climate adaptation. If I haven't mentioned the topic that you're interested in, don't be shy, apply. We're going to look at everything in this whole water utility sector. We look forward to receiving submissions and supporting you. Professor Teasdale and I bring very different backgrounds to this, but between us, we've said if we don't know, we know who knows. So put in your application and let's see where it goes.